We're going to take our Spirent graphical user interface, our Spirent application GUI. If we go ahead and we look here, we'll see that I am running 442. I'm not actually connected into any devices right now at all. What I'm doing is I'm going to create our base TCC file. There are certain defaults, system defaults, configuration defaults, etc. that Spirent has that for our purposes we find that other tuned defaults we prefer. So that's what we're going to go ahead and do is we're going to create our base TCC file that we put on our PCs, and this is it right here. So what we're going to go ahead and do first is we're going to go to Tools, and we're going to go to User Defaults Manager. I'm not overly keen on certain values that were chosen as defaults. If you see, you can actually see right here, this one might kind of scream out to you a little bit. So if I were to create a device, the default value for the TOS for that is supposed to be a Charlie 0. That's not what I want. I don't want anything to have a TOS or a COS of anything other than 0 unless I create it in the stream. So we're going to go ahead and take these VLANs, which have a COS of 7 as their default values, and we're going to change them. We're also going to go ahead, and we don't tend to use 192.85 too often. We tend to use 10 network address spaces. So I'm going to go ahead and I'm going to go in here and I'm going to change this to a user. I would prefer a 0. And so all of these are going to be 0. And for the IP addresses, I also don't like having the 4th octet as a 3. It's not uncommon that the devices that we're testing are have some type of first hop router redundancy in them. And for example, HSRP or VRRP, it's also not uncommon that people will have, if they have 2 routers, one is a .2, another is a .3, with the HSRP or VRRP value as a .1. So I don't like actually having the 3rd octet and the 4th octet as a .3. So we're going to make this 10.101.101.10, and then we're going to make the default gateway 10.101.101.1. All this means is that when I create a device, and we'll look at this later, these are the default values that it will start with. One of the reasons why I like changing the TOS and COS settings is because when I'm creating devices, I don't necessarily seem to look at those as much as I tend to look at the IP addresses, but more on that in a bit. There's one other thing that we also tend to change, and that is the deficit idles. You can actually go up into the filter and click deficit and then just move these over and switch them from being false to being true. So we're going to go ahead and do that. And so these are the default values. As you see here, user defaults added to the table on the right will override system defaults whenever new objects of that type are created. So these are the ones that I like. The next thing we're going to go ahead and do, if you look over here, it says all devices, all traffic generators, all stream blocks, all traffic analyzers. There is nothing in the User Defaults Manager that allows me to override the default multicast group that Spirent has on their test centers, which is actually 225.0.0.1. I don't like that, and it can cause problems. So in order to change that, I'm going to come into Technologies, click on IGMP/MLD, and when I click OK here, you're going to see that over here, where there are 4 different categories, when I click, Multicast Groups is now going to be in there. So I'm going to add Multicast Groups, and I'm going to change this from a default of 225.0.0.1 to 239.1.1.1. The issue that I have with the default is that the 3rd octet is a 0. So 225.0.0.1 will actually overlap with the destination MAC address for 224.0.0.1. Not something that I really want to be doing. So while I don't necessarily know if the end user who's going to be using this base TCC file will actually be doing any multicast, but if they are, chances are they'll go ahead and go with whatever default I have in there, as opposed to just going with the default that they use and having that as a base. So let's go ahead and also look over at settings. So if we go to settings, there's nothing in here that I actually changed. Device addresses, ARP is all good. L2 learning, all good for what we use. Traffic, delete inactive streams. And I do want to point out that if you want to go ahead on your own, I would very strongly encourage you going ahead and exploring this. Press the F1 button, get a little bit more information on these things. For us, I want to delete inactive streams from memory. They're inactive, I'm not using them, please delete them from memory. PHY options, traffic results mode, L2. This is where we're going to be making a lot of settings. Clear result settings. So when I click the clear results button, I want to clear results. What we're going to do is when we click clear results, we're going to automatically stop clear results and restart traffic on all ports. Also going to automatically stop clear results and restart all analyzers. We're also going to delete all analyzer streams when clearing the results. The other thing is we do use DRVs, which are dynamic route views. At least I believe that's the acronym. And we're going to go ahead and set that at periodic and have a default of 10. One other thing we're going to go ahead and change is over on BGP. When we are doing a test, specifically a scale test, we don't really want the Spirent to actually be the bottleneck. So I want the Spirent to go ahead and slam my router pretty much as hard as it can. So we're going to tell it to do that. So instead of 2,000, we're going to say go ahead and give me 65,535 max routes per update. Don't wait 30. Please go ahead and only wait 1. And then we're going to keep all of the other values except for right down here for scalability mode. Scalability mode would mean that the Spirent TestCenter is actually going to take all of the NLRIs that I have. Well, let's say that I actually have the Spirent TestCenter pretending it's 800 BGP peers, and I'm trying to see how quickly I can get things to work over on a route reflector. So it's not that the Spirent TestCenter pretending that it's 800 BGP peers really needs to hold all of the different updates. So we have it by default as discard updates. We also do not do enable TCP no delay. We actually do pack updates up to MTU. So that's what we do. So that's all in the settings. So let's go ahead and now look at how we like some stuff. For right now, if we go to devices, there's not really a lot up here. And it's kind of hard to figure things out. So what I'm going to do is I'm going to create 2 devices. I can either create a device underneath the actual port and click device and go to add, or I can come up here to all devices. Personally, when I'm adding devices, I tend to do it underneath the specific port on the Spirent that I want to use. So if we actually come here, we'll see, this will look familiar, 10.101.101.10 and 10.101.101.1. These were actually the default values that I had put in for the system defaults as opposed to the 192.85. This also is 0 as opposed to the default of Charlie's 0. So we're going to go ahead and just take that because these are offline ports and I don't really care. Then we're going to go down to this port and we're going to add another device on it. And again, we're going to go ahead and if we wanted to have a VLAN, we would actually click it here and say how many we wanted. So if we wanted 1 or if we wanted 2. But for right now, we're going to go ahead and just do this. All we're doing is setting up the base TCC file. So we're going to go ahead and change the 3rd octet to a 102, 102, next, and finish. Now, we're going to then go up to, after I create devices, I then tend to go up here to all devices. At the all devices, what you'll see is these are all the different devices. And there's the port name and the device name. I could have given it a device name. For the base TCC file, we don't go into device names. These are just offline ports. These are just something that people can use if they're not familiar with the Spirent as a starting point. Now, let me ask you a question. Where are my IP addresses? Okay, another thing I'm not necessarily keen on with the way that the Spirent actually starts this all up. If we move over, nope, not there yet. Move over, nope. Oh, look, keep on moving over. Look, there they are. Okay, that's not where I want them. When I look at the devices, I don't really care about a lot of this stuff. I want the VLAN number. If you have a VLAN, I want the IP address, I want the mask, I want the default gateway, and I want to know what your MAC address is. So let's go ahead and go here. We're going to highlight this. We're going to go to Customize View. So again, I don't care about incoming links. I don't care about outgoing links. I don't care about encapsulation. I can come down here, and I do care if I have a VLAN. Now, if I have more than one VLAN, I might go ahead and pick VLAN 1 and VLAN 2, but that would be different. So I'm going to go ahead and come up here and do this. And I'm also going to go back down, so I'm going to move it. The other thing I am going to go down and get is I'm going to go ahead and I'm going to go down and get everything having to do with an IP address. And I'm going to actually intentionally accidentally move it too far up. So now we have my device count, which is way over here, which I would actually prefer to have be over here. So I just go over to the column, click it, and drag it over. And now I have the port name, the device name, the tags, which we don't set up certain tags in the default base TCC file, the device count, oh look, my IP address, my prefix length, my default gateway. Now the step modifier default is a .1, goes up by 1. I'm going to go ahead and remove this column. So yet another thing that you can do. You can drag one, you can remove just one. So this would be something I would probably potentially do. Another thing I might do is go ahead and go way over here and drag the source MAC address. Or another thing I might do, since as you see this is kind of sort of a bit of a dragging, is I might customize the view and then do it again. So if we look at this now, I actually have right here, I have the device count, I have the IP address, the mask, the default gateway, and my MAC address. Pretty much all the things that I care about as far as this device. The next thing we're going to go ahead and do is we're going to go ahead and create a stream block. My default stream block in a lab environment is typically always point to point. So we're going to see that we want to have these two talk to each other. They are offline. The default is pair. That's typically what 99% of my traffic is for a test environment. Well, 90%. I want bidirectional because I don't just want this device here to talk to this device only. I would like them to talk to each other, bidirectional. I always click show all headers and then add it. I want my stream block to only have one stream in it. A lot of traffic that we're doing from a test of a proof of concept perspective also has to do with failure, so I want to know exactly what failed and exactly how many packets were lost. So we're going to go ahead and go to next. Byte size, 128 and 1500 I stay away from. 1500, I'm sure, as you can understand, if I was coming in and I was then going to be going into an L2 VPN network or an L3 VPN network, both of those would actually have at a minimum 2 MPLS labels on it. Or let's say I was going to go ahead and come in and go via OTV or some kind of encapsulation. So 1500 as the end user sending it would then potentially hit MTU issues in the middle. So I go ahead and I go with a 1024. And then I usually just hit next here. I typically always do for the default base TCC file an example of rate-based and frames per second and 1000 frames per second. This to me is the safest, simplest to do. And so now you're looking at this, and again, similar to the device thing, there's a lot of information here that I just told you about. For example, I'm sending 1000 frames per second. My frame size is going to be 1024. Well, where is that here? So again, we can either go ahead and we can customize views or we can remove columns. So for right now, we're going to go ahead and we're going to remove, we're going to customize the view. We're going to move, we're going to come down here. I don't care about control by, because for us, control by is always controlled by the generator. I also don't care about the traffic pattern because I always do pairs. The type port is always port for me. And then I'm going to go ahead and click OK. Now we're getting a little bit closer. And now let's say that I want to go ahead and move the index over. So we're going to do some of this via the customized view and some of it via dragging. If we look over here and we see the 1000, so 1000 frames per second, we're going to go ahead and we're going to drag that over. And it's fixed. And we're going to go ahead and get rid of the traffic group. So remove this column. And where's my 1024? 1024. Actually, what I probably do is 1024 and then fixed. So there we have all on one screen, the name, the tags, the source, the destination, the transmit port, the receive port, 1000 as my load. Load unit is 1000 is frames per second. My size that I'm sending for the frame, 1024, and that it's fixed as opposed to IMIX or whatever else. So now what we're going to go ahead and do, which I haven't done yet, is I'm going to go ahead and save this, and we're going to call it CPOC base. So it's a CPOC base TCC. I'm not too sure whether or not I just gave it 2 TCCs. Let's see what happened. Nope, that's always good. And so base CPOC base TCC. And so the next thing we're going to do is we've done defaults, we've changed the multicast, we've gone into settings and changed the settings. So now what we're going to go ahead and do is we're going to look at the results screens. So these are the results screens right here. On the results screens, you can actually look at the results and you can, where is it? Oh, the screen layout is locked. So you can actually change the screen layout, which for whatever reason I can't seem to do right now, so we won't do that. Don't know why we can't. Oh well, so I'm not going to show you that part. And so let's go ahead and go to how I like to have the results. On the base 1, what I like to do is, if you actually see this is the ports, traffic counters, send and receive. Total transmit counts frames, total receive count frames. How many bits I've received, all this other kind of stuff. I don't really care about that, and I don't want it. What I want to know is that when one Spirent TestCenter port sent traffic to another Spirent TestCenter port, did I receive it or not? I don't care about BPDUs or CDPs or OSPF hellos or other things that might have actually gone out onto this interface. I just care about the traffic. So again, what we're going to do is we're going to customize this, so customize view. And actually what I want on this screen is actually the last 2 things that they have as in the default. So I'm going to move them all the way up. And the first 2 columns are going to now be, that I care about, generating signature frames per second and receive signature frames per second. So if these were real ports, then you would have this stream over here, and it would say that you're sending 1000 frames per second, and the other one would be sending 1000 frames per second. And if this one had that it was receiving 1000 frames per second, it's because this one was sending. We'll do that in another one. Right now, again, all we're doing is just actually setting it up the way that we want to have our base TCC file. So on this other side of the screen, we're going to go to detailed stream results, and I like to be in advanced settings, and the reason is because of the fact that, of course, a lot of things that I care about is whether or not I'm dropping packets. So this tells me what reality is. I'm sending 1000 frames per second. Most of my things are going to be bidirectional, unless of course it's multicast. Am I also receiving 1000 frames per second? If this is off, then I'll look over here with my eye and find out whether or not I've dropped anything. The next view I like is the DRVs, which are the dynamic route views that actually come from Spirent now, dropped streams. And yes, I would like to have the global analyzer preload enabled. And so I want to have the drop streams, and I also want to have dead streams. So these are the two things that you run, and if you were actually running this, you would click play because these are DRVs. Don't forget to click play. We are going to make one other change though, and that is that we're going to add a column. One of the really beautiful things here is you can actually say dropped, and you can actually find what you want. So dropped frame percent. So not only do I want to know what the dropped counts were, like how many packets I've lost, I would like to know, with all the packets that I lost, what percent of my traffic was I running? Because I might have one thing running 10,000 frames per second, another thing running 1,000 frames per second. So if they both lost 10,000 frames, the percent of how much I've lost is going to be much higher on the stream that is sending 1,000 frames per second. So we'll go ahead and click OK there. The other thing we're going to go ahead and do also is, after we add that to a column, we're going to go to grouping and sorting. And I no longer really want to have the output from the DRV be based on how many total frames I've dropped. What I'd like is, again, the percent, so that the stream that actually was losing the most as a percentage of what it's sending will actually show up on top, as opposed to the one that happened to have lost more packets. And that's it. Voila, you're done. Click Save, close it. It will ask you again, do you want to save the changes again? I always say yes. I have no idea why I get asked twice, but hey, I'm okay. And then on your desktop, you now have a cpoc_base TCC file, which for us is basically our starting point for all the traffic and testing that we do.